Hey, awesome people. Welcome back. Mr. C here with you with another fractions video. Make sure if you learn anything new at all, click that like and subscribe button. Join us as we continue making math understandable and challenging. This video, we are going to focus on converting mixed numbers to improper fractions. Okay, so we're going to be taking a mixed number and turning that into an improper fraction to help us understand what is coming next. All right, if you haven't, check out the description below because we have our 4th grade fractions playlist, including a 4th grade's mixed number playlist that is available for you. Okay, check those out. We have covered a ton of stuff in 4th grade. We have covered a lot of fractions in 3rd grade. And again, all of these playlists are in the description below. Check those out. Get caught up to where we are in this video because there is so much to learn with fractions. It is really important skill to know. So check those out. In our video here, we are going to be converting mixed numbers to improper fractions teaching video. Let's get started. All right, ladies and gentlemen, before we get started, remember, growth mindset. We talk about that here with Math with Mr. C all the time. A growth mindset means that you are going to use your mistakes to help you get better. You're not going to give up when it's challenging. You stick with it. You ask questions. You try the problem. You find your mistakes. Do not give up, okay? These skills are really important, but they take practice, okay? So make sure you have a growth mindset. Today, we are going to be showing you 2 strategies, okay? 2 strategies to take a mixed number and to convert it into an improper fraction, okay? The first strategy I'm going to show you is using a model, okay? You shouldn't be too surprised by that because I use models all the time when I'm teaching, whenever I'm explaining things. Pictures are so helpful in math. Using your fingers, anything like that is really helpful, okay? So I'm going to show you how to use a model to do this. Second way I'm going to show you how to do it is by using multiplication. All right, so I'm going to show you both strategies for how to solve these types of problems, how to convert a mixed number into an improper fraction, okay? So before I jump into these 2 different strategies here, I want to kind of explain why we're doing this, all right? And I think that's really important. What we're doing is we're taking an improper fraction, let's say like this fraction here, 1 1/3, and we are turning that into a fraction. And we're turning that into an improper fraction. And remember, an improper fraction means that the numerator is larger than the denominator. Okay, so we're taking a mixed number and we're going to convert it into an improper fraction. And you're probably asking yourself, Mr. C, okay, why are we doing this? Like, what's the purpose of this? It seems kind of like a silly thing because in our last videos, we took an improper fraction, like over here on the right, and we converted them into a mixed number. So why are we doing the opposite? Well, that's a great question, okay? The reason we're doing the opposite is because very soon we are going to start adding and subtracting mixed numbers and improper fractions. In order to do that, we need to know how to convert them back and forth. Okay, this here is going to build the foundation for what's coming next when we start adding and subtracting mixed numbers. Okay, because, and you'll see soon, whenever we have 2 mixed numbers or we have 2 improper fractions, to add those together and then to convert them into a mixed number, we have to know how to do all these different steps, okay? So stick with this. I promise you it is something you're going to build on, okay? And just like everything we've done with fractions, it builds on itself. Just like when you learned what a fraction is, and then you learned how to create equivalent fractions, and then you learned how to add and subtract. It built on it, okay? So stick with me here, all right? So let me show you the very first problem. Here is our very first problem I have here on the screen. And the way we're going to solve this is I'm going to show you using a model. Okay, I'm going to show you our very first strategy for taking this mixed number, 2 1/3, and how we're going to convert that into an improper fraction. And what we're going to do is we're going to draw a model. And so what I want you to do is I want you to draw a model to show 2 1/3. Okay? So what I'm going to do is I'm going to draw a model. And what I'm going to do, like I do so often, is I'm going to draw a rectangle. And I'm going to break it into some sections. Okay? And the way I know how to do this is I look at this fraction here. Okay, so I've got 2 wholes and I've got 1/3. And the way you can think about this is 2 plus 1/3. 2 and 1/3. 2 plus 1/3. And this denominator here is going to tell us what to do with our model. Okay, so in our model here, I want you to break it into 3 equal size pieces. So there's 1, 2, and 3. Okay, and what we're going to do here is we are going to shade in this entire section. And the reason we're going to shade in this entire thing is why? Why am I shading in this whole model? Well, the reason I'm shading in the whole model is because we have a whole number of 2. So I bet you're thinking to yourself, well, Mr. C, if we have 2 holes, if our whole number is 2, we probably need 2 whole models. And you are exactly correct. And that's what I'm doing right now. I am drawing and coloring in a second hole. Here's 1 hole, here's 2 holes. Okay, do you see where I got that from? I had 2 1/3. The denominator and the third told me how many equal sections, size pieces to break it into. And 2 whole told me how many I needed to have color in. Okay, I'm going to pause myself real quick, and I'm going to tell you something else that you could have done. Okay, the reason I like to draw these thirds is because it's going to help me out later on. Technically, you could have started off by just drawing the hole and coloring it in, and that's totally cool. I kind of went ahead and did this because I think this is the best way to keep you from getting confused. Whenever you're drawing this model, take a look at whatever your fraction is, whatever the denominator is, and go ahead and draw the whole model and break it into however much your denominator is. So that's the reason both of my models here are broken into thirds. The whole thing is colored in because that represents 2 whole. Okay, here's 1 whole, here's 2 whole. All right, stick with me, okay? Now, that was our 2 whole. What are we forgetting, though? I'll put a little check mark here next to it. That's our 2 whole. What are we missing? We're missing our third. So let's draw another model. Okay, let's draw another model. And in this model, we need it to be a third. Okay, I'm actually going to draw it underneath here since that's what we were doing before. So same thing, we're drawing another model. It needs to be a third colored in because that's what our fraction tells us. So let's shade in a third. And there's a third. Okay, I'll even write it over here. There's 1 hole, 2 holes, and there's a third. If you add all of that up, what do you get? You get 2 1/3. Okay? So you've drawn your model. Now we need to write this as a fraction, particularly an improper fraction, which means that the numerator needs to be bigger than our denominator. So let's take a look at this. This is what I want you to do. I want you to count the number of colored in thirds that we have. How many colored in thirds? How many do we shade in? Let's see. We've got 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3. Do you see that? I'm going to go through it one more time. We're counting how many thirds we have colored in. 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3. That sounds a little weird, so let me write down what that looks like. This is what 7/3 looks like. Okay, this is just showing you a model. What we did was we took 2 1/3 and we drew a model for it. We took our thirds, and that told us how many equal size pieces. We have 2 holes, so there's a hole and there's a hole. Here's our third down here in this model. Count up all of the shaded in parts that we have, and that gave us 7/3. Okay, 2 1/3 is equal to 7/3. All right. So think for a second. Where are you confused at? What doesn't make sense? Do you know where this 2 hole went? Right here. 1 hole, 2 holes. Do you know where the third went? Down here in this model, there's 1/3. How did we get 7? Where did this number come from? 1, 2, 3, 4, 5, 6, 7. That's our colored in sections. Where did the thirds come from? Well, the thirds comes from every model is broken into thirds. That's why you heard me count like this. 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3. Because what will happen is a lot of times whenever you are learning this and a mistake somebody around you may make, or like your classmate or your mom or dad or aunt or uncle or somebody, what they may do is they may count every single section and go, well, the denominator is 9 because there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 pieces, so that means our denominator is 9. Not so fast. Okay? We have an improper fraction. We have a mixed number. That tells us that our numerator is going to be larger than our denominator. Okay? So, that's how the model strategy works. Okay? Let me show you the multiplication strategy. All right? Let me show you that. So to show you this multiplication strategy, I am going to change up our problem first, okay? So on the screen here, we've got 1 1/2. And what we're trying to do is the same thing, convert this mixed number into a improper fraction. Okay, so the second strategy that I'm showing you is going to be some multiplication. All right, and I think you're going to kind of like this because it's really multiplication. I'm actually going to put multiplication and addition because it's both of them. Okay, so here we go. Let me kind of walk you through this here. What we are going to say is we've got 1 1/2. Okay, and what we're going to do is we're going to take this 1 1/2 and we're going to do a little bit of multiplication and a little bit of addition. All right, this is how you do it. You're going to take your whole number, 1. Okay, you're going to take your whole number, 1. And you are going to multiply that by the denominator. Okay, we're going to multiply it by the denominator, times 2. So here's where our 1 whole was. I'm actually going to write it in some different colors here so you can see it. Here's where 1 whole was. We are multiplying it by 2. Okay. And what do you think that we need to do with this numerator? Remember, we're doing multiplication and addition. So we're doing the whole number, 1, times the denominator, times 2, and then we're going to add the numerator, 1. Okay, so this is what we're going to do. I want us to do this here. We're going to do 1 times 2 plus 1, and we are going to write that over, because it's a fraction, right? We're trying to make an improper fraction. Our denominator. What's our denominator in this mixed number? The denominator is 2, so the denominator is going to stay as 2. Okay, so watch this. What's 1 times 2? 1 times 2 is 2, plus 1 is 3. Denominator stays the same. Okay, pause for a second. Let me walk you through that one more time. We're going to take our whole number, 1. And we are going to multiply that by the denominator, 2. 1 times 2. Then we're going to add the numerator, 1 times 2 plus 1. And all of that is going to be the numerator. The denominator is going to be 2. So take a look here. 1 times 2 is 2, plus 1 is 3, and there's our improper fraction, 3/2. All right. Again, this strategy here is a lot quicker. Okay, it's a lot quicker, but I don't think it's as easy to see what we're doing. Okay, so that's the reason I'm going to recommend knowing both strategies. Okay, I like both of them. I think this one's a lot quicker, but again, we don't care about how quickly we solve things. What we care about is making sure we understand what we're solving. Okay, so let me show you another example, and let's do both strategies at the same time so you can see both of them. All right. All right, so here we go. We've got our problem here, 3 3/4, and we're going to do both strategies. Okay, we're going to start on the left with the model. Okay, so here we go. We need to draw a model and make sure that we can see what we're doing. Okay, so I'm going to draw a model, and this model here, I'm going to break it up into however many sections my denominator already is, because that's going to make it easy for me at the end. So my denominator is 4, so I'm going to have 4 equal sections. There's 1, 2, 3, and 4. And again, our whole number is 3. So I need 3 whole models. Okay, I need 3 whole models. So that's what I'm going to do. I'm going to draw 3 whole models. So I'm going to draw these, and then I'm going to shade them in, because again, 3 is my whole number. That's how many whole models I have. So I've got 2 of them. My denominator in this mixed number is 4. Okay, the fraction, the denominator is 4, so that's why I have 4 equal size sections. There's my 3. Let me shade these all in because it's my whole. There's 1 whole. Here's 2 wholes. And here is 3 wholes. Okay, now what are we missing? We've got 1, 2, 3. What am I missing? I'm missing the fraction. So let's draw another model. This time we're coloring in 3 out of the 4 sections. Okay, so we're coloring in 3 out of the 4 sections. Let's do that. There's 1, 2, and 3. So there is where 3/4 is at. Okay, so what does this look like as an improper fraction? Well, what we're going to do is we're going to count the number of colored in pieces we have. How many did we shade in? How many fractional parts did we shade in? We've got 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11/4, 12/4, 13/4, 14/4, 15/4. Listen to that again. 15/4. And there it is. We have 15 equal size fractional pieces colored in, and each fractional model is broken into 4 equal size pieces. That's the reason it is 15/4, not 15/16, because this is one whole. The models we have drawn here are whole models. This is a whole. The whole thing is colored in. The whole thing is colored in. The whole thing is colored in. That is where we got our 3 whole. Our 3/4 came from our last model here. All right, so that's where we got 15/14. Now, let's see if we get the same thing over here when we're multiplying. Okay, I'm going to rewrite this fraction with some colors so it makes it easy for us to see. Our whole number will be pink. Our numerator will be purple, and our denominator will be green. Okay, so here we go. What we're going to do is we're going to take our whole number, 3, and we are going to multiply that by our denominator. What is the denominator? Denominator is 4. Then we are going to add the numerator. What's the numerator? The numerator is 3. Take a look at this. Whole number. Multiply it by the denominator. 3 times 4. Then what we're going to do is once you've multiplied those, you're going to add the numerator, okay? Now here's the part where a lot of times people will make their mistake. What is the denominator? Denominator is already here. It stays the same. It is going to be 4. Let's multiply. What do we get? Let's multiply and add. What's 3 times 4? 3, 6, 9, 12, plus 3, 13, 14, 15. Denominator does not change. And there we go, 15 fourths. Both strategies give us the same answer. But again, this strategy on the right was way quicker. I mean, I'll admit that. Multiplication was way quicker. But do you see what we did with this multiplication? This multiplication is exactly what we did in the model. The model helps us understand why the multiplication works. Do you see where 3 times 4 came from? Look, here's 1, 2, 3. There's the 3 whole. Where did the 4 come from? 1, 2, 3, 4. 4 equal size pieces. Where did this 3 come from? 1, 2, 3 pieces. Where did this 4 for the denominator come from? Every single model is broken into 4 equal size sections. What I say all the time, being able to see what you're doing is really, really important, okay? Where did you make your mistake at? Where are you confused? What isn't making sense? Walk through this problem. Start and stop it. Go bit by bit, step by step. Find where you're making your mistake. Use that to help you get better, okay? Make sure you practice some of these on your own. If you're ready for a challenge, in the description below, you will find the practice problems video. The link is down there. Click it. Join us as we try a few more, okay? Make sure if you learn anything new at all, click that like and subscribe button. Join us as we continue making math understandable and challenging. That's all I have for you today, ladies and gentlemen. Mr. C, out.